Hello, second graders. I'm so happy today to talk to you about volcanoes. Instead of you looking at me the whole time, I figured you might be interested in watching these monstrous volcanic eruptions going on. So these are the top 5 volcano eruptions caught on camera. Here we go. So what is a volcano? A volcano is a mountain that opens downward to a pool of molten rock below the surface of the earth. When pressure builds up, eruptions occur. Gases and rocks shoot up through the opening and spill over or fill the air with lava fragments. Eruptions can cause sideways blasts or lateral blasts, lava flows, hot ash flows, mudslides, avalanches, falling ash, and floods. Volcano eruptions have been known to knock down entire forests, and an erupting volcano can trigger tsunamis, flash floods, earthquakes, mud flows, and rock falls. So how are volcanoes formed? Well, volcanoes are formed when magma from within the Earth's mantle works its way up to the surface. Remember we talked about magma last week when we were looking at our plates for plate tectonics. At the surface, it erupts to form lava flows and ash deposits. So over time, as the volcano continues to erupt, it will get bigger and bigger. So there's different stages of volcanoes. Scientists have categorized volcanoes into 3 main stages: active, dormant, and extinct. An active volcano is one which has recently erupted, and there's a possibility it might erupt really soon. A dormant volcano is one that has not erupted in a long time, but there's still a possibility it can erupt in the future. An extinct volcano is one which has erupted thousands of years ago and there's no possibility of eruption. Why do volcanoes erupt? Well, as we talked about last week, the Earth's crust is made up of huge slabs called plates, which fit together like a jigsaw puzzle. These plates sometimes move. The friction causes earthquakes and volcanic eruptions near the edges of the plates. The theory that explains this, as we talked about last week, is called plate tectonics. So there are more than 1,500 active volcanoes on the Earth, and we currently know of 80 which are under the ocean. A lot of these volcanoes are in the ring called the Ring of Fire, and I'm going to show you a picture of that in just a minute. Meanwhile, I just want to tell you a little bit about the types of volcanoes. There's cinder cones, composite, shield, and lava volcanoes. Cinder cones are cylinder and oval cones that are made up of fragments of lava from a single vent, and they've been known to blow into the air and then the cooled ash falls. Composite volcanoes are steep-sided volcanoes composed of many layers of volcanic rocks, usually made up of high viscosity lava, ash, and rock debris. Mount Rainier, which is actually in Washington, and Mount St. Helens in Washington are examples of this type of volcano. There's also shield volcanoes, which are shaped like a bowl or a shield in the middle with long, gentle slopes. These types of volcanoes are normally seen in Hawaii. Finally, there's lava volcanoes. Lava domes are formed when erupting lava is too thick to flow and makes a steep-sided mound as the lava piles up near the volcanic vent. The eruption of Mount St. Helens actually in 1980 was caused in part by a lava dome shifting to allow explosive gases and steam to escape from the inside of the mountain. So now we're going to take a little break, and I'm going to show you actually some pictures that I have. All right, class, I just wanted to show you my cool poster that I made talking about the different types of volcanoes. The first one we're going to talk about is the strato or composite volcano. This type of volcano is cone-shaped, and it's consisting of solid lava flows mixed with layers of rock. So you see here, the magma here coming up, and then solid rock mixed in. And you can actually see it really well in this picture. Mount St. Helens is this type of volcano. Next, there's the cinder cone volcanoes. And look at this. It does look exactly like a cone. And so with the cinder cone volcanoes, they don't have those horizontal layers. They actually have instead a steep cone that looks like a hill. This one, there's a very famous one, Paracutin in Mexico, that this is a picture of. And finally, we have the shield volcano. This is a flowing volcano. It's mostly or entirely from fluids or lava vents that it's made of. So you see all the lava in this shield volcano in a lava flow. It's named because when it's viewed from above, it actually looks like a shield of a warrior. Now, even though it looks like a shield of a warrior and fierce, these are normally gentle flowing volcanoes. And you can see here the lava flowing out, but not moving super fast. The most famous of this is, they're all over actually Hawaii, and Mauna Loa is one of the more famous ones. And some of you actually might have been to a volcano and might have actually seen lava flow, which is really cool. My last picture here is of the Ring of Fire. So the Ring of Fire, like we stated earlier, is where most volcanic activity occurs. And if you'll see here we are over in North America, this Pacific Northwest, and it actually does make a ring. And it goes all through, it's down in South America, into North America, through the Cascade mountain range, and then up into Alaska, and then all around. And right in the middle of the Ring of Fire, you'll see that Hawaii is right in there. So Hawaiian Islands, made out of volcanoes, is right in the center. Okay, so you guys ready to make a volcano? Let's go ahead and pull out your volcano booklet. I sent these home with you when I dropped off your supplies a couple of weeks ago. But your volcano booklet goes through some important vocabulary words. It goes through a question and answer piece in regards to Don't Blow Your Top, which is in our Google Classroom for you to read. And then it goes into our fun investigation portion. So the investigation portion, basically what you're going to be doing is you're going to be writing down your observations from your experiment. If you can't do the experiment, then you can actually watch mine and write down your observations from mine. And you're going to really think about what's going on when we're doing our explosion. Okay, so here we go. I have here my volcano, not the most pretty volcano, but it's gonna do fine. So how I made this is I actually used the recipe that I put into our Google Classroom to make clay. It involved, I think, flour, salt, cold water, and oil. There's a bunch of them on the internet, so whatever works for you, go ahead and make some clay. And then what I did is I just took a small plastic cup to build around so that I could use this in here as the chamber for when we do our eruption. Now I have baking soda and I have white vinegar. You can use any vinegar will really do. What's gonna happen is these two are going to react. So my baking soda, what I'm gonna do is I'm gonna take it and I'm gonna put it into my chamber here. And now I'm just gonna even it out a little bit. And now for the rest part, we're gonna pause and we're gonna go outside for when I do the eruption.
Hey guys, so we're just gonna pour the vinegar in slowly. And
you wanna do a little more?
Hey guys, let's just do it one more time with a little more vinegar and let's go with...
Oh, there you go. That's a good eruption, George. Awesome. Oh, the more vinegar and baking soda you have, the bigger your reaction and the more you're going to see your lava form.
Action.
If you like that experiment with the reaction of the baking soda and the vinegar, you're gonna love this one. This you definitely have to ask your parents for, but this is another type of reaction, and this one involves Diet Coke and Mentos. All right, so we just tried Diet Coke, and now we're gonna try it with regular Coke to see if we can see any difference. So let's zoom in.
2, 1, go.
Pretty good, all right. Side by side, which one do you think was more? Uh-oh, okay.
I think the Diet Coke did.
But definitely a bigger reaction than the baking soda and the vinegar. I think the Diet Coke might have won. So we just tried it with Diet Coke. Now we're going to try it with regular Coke just to see if there's a difference. She's putting all the Mentos in. Ooh, and there it goes. Yes. I'm thinking Diet Coke was a little bit bigger of a reaction. So as the Mentos candy sinks in the bottle, the candy causes actually the production of more and more carbon dioxide bubbles. And the rising bubbles react with the carbon dioxide that is still dissolving in the soda to cause more carbon dioxide to be freed and create even more bubbles, resulting in a big eruption. So this is one way you could also erupt your volcano, although I think your parents might prefer the vinegar and the baking soda. Have a great day, guys.